Hey everyone, in this video we're going to practice with arithmetic and geometric sequences. Now we've already covered both arithmetic and geometric sequences and writing them explicitly and recursively. So the challenge in this video is going to be correctly identifying which type of sequence we're working with. The key to doing that is look for a common difference if it's an arithmetic sequence or a common ratio if it's a geometric sequence. So our first example, determine if the following sequence is arithmetic, geometric, or neither. If it is arithmetic or geometric, write both an explicit formula to find the nth term of the sequence and a recursive formula. So our first sequence is 6, 1, -4, -9, -14, continuing on. The most important decision is whether the sequence is arithmetic, geometric, or neither. Looking at the terms of the sequence, if we look, seems that we are subtracting 5 to go from one term to the next. Let's see if that works out the whole way. So subtract 5 from 1, we get -4. Subtract 5, we get -9. Subtract 5, we get -14. So we do have a consistent value that we're subtracting to go from one term to the next. So that's the common difference. And that means we have an arithmetic sequence with a common difference of -5. So now we need to write both an explicit and a recursive formula. We'll start with the explicit. So remember, to write an explicit formula for an arithmetic sequence, we want to think of it as a linear function. The common difference is the slope, and then we have the first term, a sub 1 is 6, which we can express as a point, which would be 1, 6. So we're using that point slope form, but with our sequence notation. So a sub n minus 6 equals, as we said, common difference is the slope, so -5 times n minus 1. Solving for a sub n, we have 6 minus 5 times n minus 1. Now recursively, we need to determine two things. What's our starting value, the first term of the sequence, and what's the pattern? How do we go from one term to the next? So the first term, we already identified, a sub 1 is 6. And then how do I get to a sub n? Well, I take the term before it, which is a sub n minus 1. And in this case, we're going to subtract 5. So I have a starting value, and I know how to go from one term to the next, so I can create all the terms of the sequence. So this is a good point to remind ourselves the explicit formula is really useful for finding later terms of the sequence. 50th, 100th, 1000th term of the sequence. The recursive formula is really good to know where the sequence starts and what the pattern that the sequence has is. So same directions, new sequence, 2, 1, 1/2, 1/4, 1/8, continuing on. Looking at the terms of this sequence, it looks like we're multiplying by the same value to go from one to the next. So to go from 2 to 1, we would multiply by 1/2. And then times 1/2, we would get 1/2. Times 1/2, we would get 1/4. Times 1/2, we would get 1/8. So we have a common ratio through this sequence. So we have a geometric sequence with a common ratio of 1/2. So we'll start by writing the explicit formula for this sequence. So remember, to write the explicit formula for a geometric sequence, we use an exponential function. The first term of this sequence is 2. We have our common ratio. So we have a sub n equals, the coefficient is the first term. The base of the exponential function is the common ratio, so in this case 1/2. And then to the n minus 1. Remember, we have to shift the exponential function 1 to the right, so that this coefficient is the first term. Recursively, again, we need a starting value, so a sub 1 equals 2. And we need to figure out how to go from one term to the next. So how do we get to a sub n? Well, we take the term before it, and we multiply by 1/2. So we can write this as 1/2 times a sub n minus 1. A sub n minus 1 is the term that comes before a sub n. So we've done one arithmetic, one geometric, which is good to refresh our memory on both their explicit formulas and how to write each sequence recursively. Next, the sequence is -5, 10, -20, 40, -80, continuing on. So looking at these terms, looks like we're multiplying by -2, but let's check. So times -2 would be 10, times -2 would be -20, times -2 would be 40, times -2 would be -80. So we have a common ratio. So this is a geometric sequence with a common ratio of -2. So explicitly, we know that the first term is -5. That common ratio will be our base. So a sub n equals -5 times -2 to the n minus 1. Recursively, this sequence starts out at -5. We already identified that piece. And here I'll use a sub n plus 1, using that different notation that we could see in a recursive formula. So to go from one term to the next, we have to multiply by -2. The term before a sub n plus 1 is a sub n. So we can write this as -2 times a sub n. All right, so we have our explicit and our recursive formula for this sequence. Next up, -3, 5, 13, 21, 29, continuing on. So it looks like we're adding to go from one term to the next, but let's check that out. So if we add 8 to -3, we would get 5. And then plus 8, we would get 13. Plus 8, we would get 21. Plus 8, we would get 29. So we have a common difference here. So that means this sequence is arithmetic. Common difference of 8. So explicitly, we're going to write that first term as a point. So we can express it as the point 1, -3. The common difference is our slope. So we have a sub n plus 3 equals 8 times n minus 1. So a sub n equals -3 plus 8 times n minus 1. There we have our explicit formula. Recursively, the first term is -3. We already got that. And then a sub n plus 1. How do I get to the next term? Well, I add 8 to the term before it. So the term before a sub n plus 1 is a sub n. And we're going to add 8 to it. So we have our explicit and our recursive for this arithmetic sequence. Find the 81st term of a sequence with a first term of 16 and a common difference of 1.5. Now, reading this question, they don't tell us whether we have an arithmetic or a geometric sequence, but they do give us one piece of information that can help us come to a correct conclusion. And that's the fact that the common difference is 1.5. Only an arithmetic sequence has a common difference. Okay, so this tells us that our sequence is arithmetic. So our common difference is 1.5. The first term is 16, so a sub 1 is equal to 16. So we can express that as a point. So 1, 16. So we can write the explicit formula here. So a sub n minus 16 equals 1.5 times n minus 1. So a sub n equals 16 plus 1.5 times n minus 1. And now that we have the explicit formula, we have to use it. We have to use it to find the 81st term. So that's going to happen when n equals 81. So a sub 81 equals 16 plus 1.5 times 81 minus 1. Remember, we want to do what's in the parentheses first. So that's 16 plus 1.5 times 80. Next, we're doing this multiplication here. So a sub 81 equals 16 plus 120. So the 81st term of this sequence is 136. Okay, so we wrote out the explicit formula first, then we plugged in 81 to find that 81st term. Next, find the seventh term of a sequence with a first term of 3 and a common ratio of -2. So again, they don't tell us whether we have an arithmetic or geometric sequence, but by telling us there's a common ratio, that should be enough for us to realize that we're dealing with a geometric sequence here. Common ratio of -2, so r equals -2. And the first term is 3, so a sub 1 equals 3. So if we're looking for the seventh term, first thing we're going to do is write that explicit formula again. So a sub n, geometric, we're using that exponential function. So the coefficient is 3. The base is the common ratio of -2 to the n minus 1. And now we're looking for the seventh term, so that's n equals 7. So we have a sub 7 equals 3 times -2 to the 7th. So a sub 7 equals to the 7 minus 1 rather. So that's 3 times -2 to the 6th power. So a sub 7 is 3 times 64. So the seventh term is 180 plus 12, 192. Perfect. Find the 10th term of the sequence, 48, -16, 16 over 3, -16 over 9, 16 over 27, continuing on. So looking at the terms of this sequence, looks like we're multiplying by a constant value here, so let's see. If we multiply by -1/3, 48 times -1/3 would be -16. Times -1/3 would be 16 over 3. Times -1/3 is -16 over 9. And then times -1/3 would be 16 over 27. Okay, so we have a geometric sequence then, with a common ratio of -1/3, a first term of 48. And if we're looking for the 10th term, we're going to start by writing the explicit formula. So a sub n equals 48 times -1/3 to the n minus 1. And if we're looking for the 10th term, that's n equals 10. So a sub 10 equals 48 times -1/3 to the 10 minus 1. So a sub 10 is 48 times -1/3 to the 9th. Now for this one, we'll use the calculator. So we have 48 times -1 divided by 3 raised, remember that exponent key is the up arrow, to the 9th. Hit enter. Now that's a long decimal. I would prefer it as a fraction because that's how our sequence was given to us. So we can hit that math key. That first choice converts a decimal to a fraction. So we have -16 over 6,561. So -16 over 6,561. So that's the 10th term of this sequence. Find the 101st term of the sequence 17, 13, 9, 5, 1, continuing on. So here it looks like there's a common difference. Let's see if we can identify it correctly. So 17 to 13, that would be subtract 4. 13 to 9, subtract 4. 9 to 5, subtract 4. 5 to 1, subtract 4. Okay, so there's a common difference. So we're dealing with an arithmetic sequence with a common difference of -4. The first term is 17, which we can express as a point, 117. So to find the 101st term, let's write the explicit formula first. So a sub n minus 17 equals -4 times n minus 1. So a sub n equals 17 minus 4 times n minus 1. Now we're looking for the 101st term, so that's n equals 101. So a sub 101 is equal to 17 minus 4 times 101 minus 1. So again, we're going to do the subtraction inside the parentheses first. So 17 minus 4 times 100. Next up comes the multiplication. So 17 minus 400. So the 101st term here is negative 383. Perfect. In each of the last few examples, we still had to write that explicit formula, but then we used it to find a specific term in the sequence. Explain why 48 is not a term of the arithmetic sequence given below, which is a sub n equals 15 plus 2 times the quantity n minus 1. Well, the first important thing that we have to remember is that the domain of a sequence is the whole numbers. Typically, sequences have a first term, a second term, a third term. There were rare cases where it had a 0 term, first term, second term, third term. So we use whole numbers to define the domain of a sequence. So what does that mean? I should be able to plug in a whole number into this formula and get out 48 if it was a term of the sequence. So since it's not a term, that means that the n value that we would have to plug in should not be a whole number. Okay, so now that we have a goal in mind, let's show that to be true. Okay, so if a sub n equals 48, we're trying to figure out what n is, and as we just talked about, we're hoping that this is not a whole number. So we get 48 equals 15 plus 2 times n minus 1. We'll start by distributing the 2 out, so 48 equals 15 plus 2n minus 2. So 48 equals 2n plus 13. We can subtract 13 from both sides. So we would have 35 equals 2n. And we can divide both sides by 2. And we would get 17.5. Kind of looks like an 11. Let's make that a better 17. 17.5 equals n, which is not a whole number. And that's what we're hoping for. So that means that 48 is not a term of the sequence. Now we have to explain. So we could say, since the domain of a sequence is the whole numbers, and 17.5 is not a whole number, .48 is not a term of the sequence. So that very nicely explains everything we talked about in this example. Refresh our memory on the domain of a sequence being the whole numbers, right? 0, 1, 2, 3, 4. And then it shows us how to prove something is not a term of a sequence by showing that the n value we would get would not be a whole number. Our last example, consider a sequence with a first term of 81 and a fourth term of 3. Assuming n is greater than or equal to 1, write a formula to find the nth term of the sequence if it is arithmetic and if it's geometric. So basically what we're doing is we're taking the same two terms that we've been given. In one case, we're thinking about them as terms of an arithmetic sequence, and in the other case, we're thinking about them as terms of a geometric sequence. So what we can do is we can split the page right down the middle, and let's start by thinking of these two terms as terms of an arithmetic sequence. So the first term is 81, so a sub 1 is 81, and the fourth term is 3, so a sub 4 equals 3. So we can express both of these as points, so 1 comma 81 and 4 comma 3. So we have two terms of the sequence, we don't have the common difference, which is really just the slope between the points. So the common difference, I'll use the correct notation, is going to be 3 minus 81 over 4 minus 1. So we have negative 78 over 3, which is going to be negative 26. Okay, so now we have two terms and the common difference. So we can write the explicit formula. So a sub n, I'll use the first term since that's the easiest, minus 81 equals negative 26 times n minus 1. So a sub n equals 81 minus 26 times n minus 1. We could have used the fourth term. This would have been a sub n minus 3, and then we would have had n minus 4 here. Both are correct. Now, for a geometric sequence, again, let's write out those two terms. So a sub 1 is 81, a sub 4 equals 3. So in this case, we need to figure out what the common ratio is. Now, the best way to do that is use this first term and write as much of the explicit formula as we can. So right now, the explicit formula a sub n equals, the coefficient is the first term, so 81. Don't know what that common ratio is, to the n minus 1, because we're using the first term. Now to find the common ratio, we can use the other point that we've been given, which is the fourth term is equal to 3. So a sub 4 equals 81 times r to the 4 minus 1. So the fourth term is 3, so 3 equals 81 times r to the third. Now we want to divide both sides by 81 to isolate the r cubed. So we would have 1 over 27, if I simplify that fraction, equals r cubed. We can take the cube root of both sides. So in order to take the cube root of this fraction, just cube root the numerator and the denominator. So the cube root of 1 is 1. Cube root of 27 is 3. And that's equal to r. And again, cube root is what number times itself 3 times is equal to 27. So 3 times 3 times 3. So we found the common ratio. So we can go back into the explicit formula that we wrote without the common ratio and put that in. So a sub n equals 81 times 1/3 to the n minus 1. So we took the same two terms. In one case, we treated it as an arithmetic sequence, and we came up with a sub n equals 81 minus 26 times the quantity n minus 1. The other case, we treated it as a geometric sequence, and the explicit formula was a sub n equals 81 times 1/3 to the n minus 1 power. So, a lot of practice with arithmetic and geometric sequences in this video, mainly identifying what type of sequence we're dealing with, and then writing an explicit or recursive formula for the sequence. So, now it's important that you go and practice as many questions as you can so that you feel confident in correctly identifying what type of sequence you're dealing with and answering the question, whether that's writing the formula or finding some later term in the sequence. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.